Alright guys, so I'm in my garage this morning and I'm actually going to make use of the space I have here and the circular objects I've got in the garage to help us prove what pi equals. We know that pi is that symbol right there, and don't mind my pointer, this fancy broom handle. We know that pi is an approximate value of 3.14. I think we're really used to that value, but where does it really come from? Well, pi, if you don't know, is a ratio. Pi is nothing more than a ratio, and we know ratios can be represented as fractions. In this case, relating to circles, it's the ratio of the circumference. So if I had a circle, it would be the distance around that circle, our circumference, divided by the diameter, the distance across the circle, okay? So with any circle, the more precise we can be in figuring out the circumference, the distance around, divided by the diameter, the distance across, the more precise we can be, the closer we're going to come to that value of 3.14. Okay? So before we can get started, we need to have some useful measuring tools. So you can see I've got a whole bunch of measuring tools to choose from here. I've got a ruler that's on the ground. I've got a couple different tape measures. One's a steel tape measure. Actually, let me get that close enough to you. I've got the steel tape measure. The problem is it's not very flexible. So the steel tape measure, and for that matter, the ruler are good for probably helping me measure, if I'm going to use my bike tire as an example, help me measure the diameter across, because that's a nice straight path. But I'm going to have trouble measuring the circumference because my ruler certainly isn't flexible and this steel tape measure is not flexible. If you're lucky enough to have one of these kind of lighter weight metal or sometimes nylon tape measures, it's also going to be good at measuring across your diameter. And what I like about this one is it's actually got a hook that's going to make life a little bit easier for me to more precisely measure my diameter. And I guess it's flexible enough. If I want to take the tire off the bike and wrap it around, I could probably accurately measure the circumference, okay? Another way of getting around that, as long as you have a ruler, is to use some string. And what you can do is, especially for measuring circumferences, you can wrap that string around your circular object. And as long as you know where the beginning of your string is, and once you mark, let's say I've wrapped it around, once you mark where you are ready to overlap again, you can measure the length of that string. And that's the equivalent of measuring the distance around your circular object. So if I wanted to, maybe I lay that bike tire down flat after I take it off the bike, and then I wrap the string around and I very carefully measure as best as I can what the length of that string is, and that would represent my circumference, okay? What I'm going to do, I'm going to hit pause for a minute, is I'm going to show you another creative way, and you can begin to see some of the markings I have on the floor. So bear with me for a moment while I get things set up. So another thing you can do, and this is what I'm going to do with my bike tire, is you can mark a spot, and since my bike is upright, I'm going to mark a spot on my tire at the very bottom of the tire, and then I'm going to transfer that spot to my garage floor. And now I'm just going to simply roll the bike, keeping track of that spot until it winds up back down at the very bottom again. Now, I did this earlier, and you're going to have faith in me that where my spot winds up, as long as it's at the very bottom, is right at that blue line there, okay? Now, you can do this with any circular object where you mark a spot and you transfer it to your flat surface. So you could take something that's round, like a cover of a coffee can, mark it by laying it upright, almost like the tire, mark it on your table, maybe with a piece of tape so you're not marking up the table, permanently. Roll that until you get a full rotation, and that full rotation is going to be the equivalent of the measurement around your circular objects. It's going to represent your circumference. So I've gone about doing that already. So don't forget, we know pi, the more precise we can be, is going to be a value of 3.14 based on the ratio of dividing the circumference I'm going to get my pointer again, dividing the circumference by the diameter. In this case, my circumference, that distance from there to there, one full rotation, was 76 inches. My diameter, when I used my tape measure and I measured across the tire, was 25 inches. So now I can simply divide, because a ratio is nothing more than a division problem. It's a fraction, right? 76 divided by 25, I get 3.04, okay? Now again, pi is 3.14. My measurements, as precise as I could be, was 3.04. So I'm in the ballpark. And I'll emphasize again, the more precise you can be, the closer you're going to come to that value. So I want you guys to find something circular in your house, use whatever tools and creativity you need to take two measurements, your circumference and your diameter, record those two values, divide those two values, and come up with your answer. Now here's the thing, I want you to round this to the fourth decimal place. That's the 10,000th place. Okay, so that means you're going to have to take it out 5 places to round back to the fourth place accordingly. And let's see how close you can come to 3.14. Okay, so you're going to have to do a little bit of research, and then I'm going to post a Flipgrid assignment, and I'm going to explain to you how to condense all that down into about a 90-second or less presentation based on your circular object, your measurements, and your final calculation. So be on the lookout for more information.